superconductivity, 2 lines of the syllabus. What they have written? What they have written into the syllabus? Superconductivity, Meissner effect, Josephson junction, and high temperature superconductivity. This is one of the most researched topics of the 20th century, where more than 8 Nobel Prizes have been bagged in last 50 years, after 1950 onwards. So only 3 topics have been written in the course: Meissner effect, Josephson junction, and high temperature superconductivity. So what is superconductors? In 1911, Kamerlingh-Onnes is famous for what? He is famous for liquefying gases. He is the person who was trying to liquefy gases, and liquefaction of gases occurs at extremely low temperature. So he was liquefying gases, and then he stumbled on the mercury, Hg, and when the temperature of mercury was lowered to the 4.2 kelvins, its resistivity dropped down to 0. So in this scale I am talking rho. Rho means resistivity, and conductivity is reciprocal of rho. Everybody knows. Reciprocal of that is conductivity. So in this scale was temperature. That is how typically, as the temperature was reduced, resistivity drops. But when the temperature was 4.2 Kelvin, then resistivity has suddenly gone down to 0. This observation will open up lot of new experimental ideas. Resistivity 0. Then what is the simple consequence of resistivity 0? Conductivity is infinite. Very large conductivity. Very large conductivity. It will throw up great ideas. Like when the conductivity is 0, it can give rise to currents uninterrupted for many years. Otherwise, you can see whenever from any conductor, if you see current from the source, you just travel some 50 meters from the source, current drops down. Correct? Current starts attenuating. And for time being, how many times from any source you see current attenuates? Is not uninterrupted. So if the resistivity is 0, then the material, this kind of phenomena was called superconducting. It is not conductor, it is superconductor. A new state has been reached. It is very extremely high. Here this conductivity becomes extremely large values. So conductors is having finite value of conductivity of the order of 10 raised to power 7 or so. Infinite means it cannot be measured. It's such a high resistivity has become 0. So it was new kind of phenomena, new kind of material, new kind of state of matter. So it is different from conductivity. Right? Understand? It is not high value of conductivity. It is superconductivity. It is new kind of phenomena where resistivity drops down to 0. Then conductivity becomes infinite. While normal conductors are having finite value of conductivity. And normal conductivity is due to what? What is the theory? Free electron theory. It was due to presence of even their free electrons. Semiconductors, 3 kind of materials on the basis of electrical property. Materials are insulators, conductors, and semiconductors. On the basis of value of resistivity and conductivity are not 2 independent virtues. They are only one property, correct? They are only one property. Okay, reciprocal of other one is called other one. Good. Conductivity is reciprocal of this. So either on the basis of resistivity or conductivity you can classify materials into insulators or conductors, or in between. Conductors are having high value of conductivity of the order of 10 raised to power 7 ohm meter inverse. Good. Siemens per meter. 10 raised to power 7 SI units. मालूम है ना भाई? नहीं मालूम तो याद करना चाहिए. सबको मालूम होना चाहिए. 12वीं क्लास की चीज है, 11वीं क्लास की चीज है. पहले चैप्टर में यही मालूम होना कंडक्टिविटी की वैल्यू क्या है कंडक्टर्स के लिए. So electrically, I classify the materials into conductors, semiconductors and insulators. Insulators are having extremely small value of conductivity, extremely small value of, high value of resistivity of the order of 10 raised to power 7. So conductivity will become 10 raised to power minus 7. Very small value of conductivity for the insulators, and semiconductors are in between. So what is the conductivity of conductors? To explain the conductivity of conductors, we have taken the free electron theory, that is due to valency electrons. Valency electrons are free to move inside the conductors and they are responsible for conductivity. Good. So conductivity was sigma was n e square tau by m. N was the number of charge carriers. M was inversely proportional to mass of the charge carriers. So if it is due to ions, conductivity is small. If due to electrons, conductivity is high. So conductivity की value क्या थी from free electron theory of metals? Sigma was n e square tau by m. यानी the number of charge carriers per unit volume, m was the mass, tau is the relaxation time. So for your conductors, it was due to free electrons and ions, any particles that were responsible for conductivity. For semiconductors, it was due to electrons and holes. It was due to electrons and holes. Insulators, it was no conductivity. Dielectrics, it was dielectrics, correct? Insulators, high value of dielectric. So how first of all, superconductor is different from conductor, and you have to find out what the difference between superconductors and conductors. Superconductors are those materials which is a new state of matter, where sigma is infinite, very large, extremely large values, which cannot be measured, while conductors are having finite values. Conductivity is due to free carriers. Here it is not due to free carriers, it will be due to Cooper pair of electrons. We will explain a new kind of phenomena we have to explain. Good. Conductivity was due to free electrons. Valency electrons of the metal were responsible for finite value of conductivity, that was the conductors. So a question, a fundamental question, what is the difference between conductor and superconductor? They are two different phenomena. Two different phenomena. We will, two basic things I have told you, sigma infinite, sigma finite. Then this will be due to free electrons. Here it is due to Cooper pairs. We will talk what is Cooper pairs. We will explain them. It is due to Cooper pairs. They are fermions. Basically that was what? Free electrons was what? Fermions. Obey Fermi-Dirac statistics. It is not due to fermions. It is bosons. Two electrons will form bosons. That Cooper pair of electrons. How will they be responsible? We will talk in due course of time. Two basic differences. Other differences also we will see. Other differences also you have to write. Extremely important things, you have to write down the difference between what are the conductors and what are superconductors. Conductors are metals. For example, what are the good conductors? Metals are good conductors. Copper, iron, copper, aluminum, so on and so forth. But they are alloys. Typically they are alloys of rare earth elements. Most research material is yttrium, barium, copper oxide, YbCO. Most research material is YbCO, yttrium, barium, copper oxide. They are alloys of rare earth materials. Then अभी हम थोड़ी देर बाद बताएंगे आपको. Superconductivity is the phenomena of perfect diamagnetic state. Material is perfectly diamagnetic. That kind of thing is not there, not required for conductors. This is a phenomena of perfectly this. Valency band and conduction band in conductors was overlapping. Valency band and conduction band in conductors was overlapping. That is how easy conductivity was there. From valency band they can easily, charge carriers can go to conduction band. Good. Conductivity was, high value of conductivity was a consequence of overlapping of valency band with the conduction band. While here there is a gap, 2k theta d. K is the Boltzmann constant. Theta d is the device temperature. That kind of gap is there between conduction band and valency band. 4-5 अंतर बता दिए मैंने शुरू में ही. What is the difference between conductor and superconductor? So for mercury it was reached at what temperature? 4.2 Kelvin. Below above 4.2 Kelvin is normal material. Below 4.2 Kelvin, superconductor. Correct? So this is called transition temperature or critical temperature. Tc at 4.2 Kelvin it reduces to what? Superconductors. Good. Conductivity dropped down to 0. But this temperature is so small that this kind of material cannot have any commercial or industrial applications, because maintenance of this temperature itself is highly costly, not economic. So we have to make the progress to increase this temperature to a manageable limit. Increase this transition temperature, critical temperature or typically we call transition temperature, because critical temperature we will call something else. So it was 1911, it was for mercury, later on it was discovered for other kind of materials also, and efforts have been run to raise this temperature to manageable limits. Till now it is 142 Kelvin has been achieved. What temperature has been achieved? High temperature superconductivity. I need to teach nothing. High temperature superconductivity means how the transition temperature has been raised. So in 1911 to your 2016, how much is the progress? We have come up to 142 kelvins. ठीक, उसी में है. Many materials have been discovered. We will talk in due course of time. So first of all, to bring it to the manageable limits, is it clear what is superconductors? We will explain superconductivity. First of all, up to 1957 there has not been any satisfactory explanation for superconductivity. Up to 1957 there has not been any theory which could be explaining all the observed properties of superconductivity. So first of all, only up to 1950s there was survey, different kind of materials, how to raise these transition temperatures. Different people researched on the nature of these materials, what could be the applications of these materials. Magnetic leviated trains can be manufactured. Memory elements in the supercomputers can be made from them. There can be many other applications. To devise very sensitive magnetometers, another application could be, there could be lot of applications of superconducting materials if they can be produced to the manageable temperature. Most important aspect is that should be this transition temperature has to be raised. So before 57 there has not been any explanation for this. So only explanation comes in 1957, that is called Bardeen-Cooper super theory. What theory? BCS theory. 1997 नहीं 1957. ईयर वीयर की इंपॉर्टेंट नहीं है फिजिक्स में, लेकिन बता दे रहा हूँ क्योंकि क्रोनोलॉजिकली अंडरस्टैंडिंग द थिंग्स इज सिंपलर. बार्डीन कूपर एंड सिल्फर theory, that is called BCS theory of super. This theory also explains superconductivity up to transition temperature of 100 kelvins. Beyond 100 kelvin, this is also not able to explain all the properties. This explains almost all properties. There is a limitation of this theory also. Explains almost all properties of superconducting materials below TC 100. ठीक है भाई, तो अभी बताएंगे व्हाट इज द थ्योरी, बट मोस्ट इंपॉर्टेंट एस्पेक्ट इज 50-100 साल तक होता क्या रहा, ओनली दे हैव बीन सर्वेइंग द प्रॉपर्टी. So there are large of number of properties are there, thermal properties, magnetic properties, electrical properties, different kind of properties are superconducting material. हमारे कोर्स में सिर्फ 2 लिखी हुई हैं. कौन कौन सी? मेसनर इफेक्ट एंड जोसेफ्सन जंक्शन. ठीक है, हम 1-2 और बता देते हैं संग संग आपको, और मुझे किसी भी ज़्यादा प्रॉपर्टी बताने का कोई यूज नहीं है, आप किताब से जाके पढ़ सकते हैं. ओनली 2 प्रॉपर्टीज आर रिलेवेंट, मेसनर इफेक्ट एंड Josephson junction. Try to understand this superconductivity can be destroyed by use of magnet. All of them are empirical, experimental. All the properties, whatever I am saying, they are what? Experimental. By the application of magnetic field, superconductivity can be destroyed. पहली प्रॉपर्टी बता रहा हूँ आपको. By application of magnetic field, superconducting stage can be destroyed. Means it will become normal conductor. There will be transition. By application of magnetic field, superconductivity can be destroyed. By application of magnetic field, it was experimentally researched that whenever we apply magnetic field, superconducting state can be destroyed. The magnetic field required to destroy superconductivity is called critical magnetic field, and the temperature at which it is destroyed, it is called critical temperature. इसलिए TC नहीं लिखा था वहां पर मैंने. Good. What is the first line I have said? By application of magnetic field, superconductivity can be destroyed. So now BC is a critical field at temperature T required to destroy superconductivity. BCT is critical field at temperature T. BCT is BC0, critical field at temperature 0, 1 minus T upon Tc whole square. BCT is BC0, 1 minus T by Tc whole square. ऐसा ग्राफ है. For a particular any superconductor, this is the typical graph. This is this. This is T is equal to Tc. T is equal to 0 पे BC 0 है. T is equal to 0, it is BC 0. Definitely T is equal to 0 cannot be reached. तो हमने critical field criteria बनाया है. Otherwise everywhere. यहाँ पर आराम से समझ सकते हैं. Whenever I put T is equal to 0, if I put here T is equal to 0, ये क्या हो जाएगा? BC 0. BC 0 is BC 0. That is critical field at 0 Kelvin. BC 0 here is what BC 0? BC is the critical field required to destroy superconductivity, and BC 0 is the critical field at temperature 0. Temperature 0 Kelvin. At T is equal to Tc क्या हो जाएगा? BC is 0. As T is equal to Tc, BC is 0. So below Tc superconductivity is destroyed. Before that it is superconductor, it is non-superconductor. Below Tc the material loses out to be non-superconducting. So at what is the critical field required to destroy superconductivity, I can always find. If I know Tc is the critical temperature, transition temperature. Tc is the transition temperature. Then I can find out at any temperature T, by application of magnetic field at a particular temperature, superconductivity can be destroyed. This is the formula. समझ में आ गया? फार्मूला सब्स्टिट्यूशन प्रॉब्लम पूछी जाती है, न्यूमेरिकल प्रॉब्लम, इसका कोई डेरिवेशन नहीं है. क्या कह दिया मैंने आपको? इस फार्मूले का कोई भी डेरिवेशन नहीं है. दिस फार्मूला कम्स फ्रॉम व्हाट? empirical experimental. 3 times a numerical problem has been asked. Formula substitution